Hello, everyone. Good afternoon. Uh, I'm Dave Rubenstein. I'm editor-in-chief of SD Times, and I want to welcome you to today's program. It's called It's Data First When Modernizing Applications. Before we get started, I have just a couple of brief housekeeping announcements. And those would be one, that this is going to be followed by a live Q&A. So if you have any questions, you can type them into the panel. Into your control panel, go to the questions tab, type in the question. We'll get to as many as time allows. Secondly, we're going to be recording this presentation for on-demand viewing at a later date, and that should be available tomorrow on sdtimes.com. Okay, so organizations today are looking to modernize their applications, talking about breaking them into things like microservices, putting them up in the cloud, and many are finding that they're struggling with that. So it turns out that the key to successful application modernization is hidden in your data models. So here to discuss that today with me are Brandon Tilke. He's the chief software architect at software dependency mapping company CodeLogic. And with him is Eric Minnick, who is CodeLogic's DevOps evangelist guy. So I'm going to throw it over to Eric now, and he will start the presentation.
All right. Well, thank you, David. Really good to be here with you all. This is a topic that is just so important, and I know I'm really excited to talk about and share with you all. So hopefully we can share some wisdom here. And before we get into it, we talked about modernizing applications, and would like to just open with a quick poll around what you guys see out there as a big challenge with modernizing apps. And you'll find in your GoToWebinar panel over by polls, it'll say poll is open, and you can go ahead and share what's challenging you. So if you do that, that'll really help us tailor the conversation and make sure we're talking about the right things. Cool.
All right.
All right. See, I feel like this is a little bit like popcorn. When the answers stop coming in, maybe we call it. Because we can give it another 20 seconds. Here we go. Yeah, okay, so looks like, yeah, all these challenges are relevant to some of you, and then learning that legacy code base. Yeah, we hear that a lot. Like, we've got some code base that's been neglected for the last 15 years, and we have like 2 people who spend some of their time on it, and now it's the most important thing to modernize. What are we gonna do here? I know, Brandon, you've had to like jump into old code bases, and it's a lot of fun, right?
It's always a challenge. Yeah, find some interesting things in that process.
Yeah, and like you're trying to figure out like what's going on here. It's like, is there any documentation for this? And usually no, but if you're lucky, like we're seeing, like there's the smart guy who has been working on this and did develop some of it and has a good chunk of the knowledge in their head, right? If you've got that, that's at least somebody understands the system. And half the time when you pile people on, like that person just gets slammed, right? On newer systems, you get like the whiteboard of truth, and maybe not any systems in the last year, but I mean, Brandon, you've definitely had like this whiteboard of truth, right?
We've had that whiteboard, and I was actually talking to someone the other day who they had actually shrink wrapped their whiteboard so that nobody could even get to it. I mean, not to mention you couldn't erase it if you wanted to because it's been there for so long, but they actually shrink wrapped the thing just to prevent anyone actually touching it. So yes, I've seen this.
Yeah, there's some information there. And then like if you do have the adequately legacy system, like someone might have this Visio diagram that we have out on the right, where they've stitched together how it all fits, and like that was probably approximately true-ish at some point in the past, and its relationship to now, I don't know. Is it even useful, Brandon? Like,
I mean, I'm sure it was really useful when you first started out. This is exactly what it was intended to look like. And shortly after you began, not so much. Yeah.
Right. Everyone who writes code, that's architecture. A lot of people have written code since that was made. Oh, yes, good. So like this general problem of like trying to understand it, like that's why I'm here. That's why Brandon's here, I think. For me, I come from a DevOpsy background, and I look at all the tools in DevOps land, and so many of them exist to kind of accommodate crummy architecture or architecture you don't understand. Right? All the fancy mocking tools like service virtualization, right? Or to kind of do some decoupling where you're highly coupled. I come from the release automation space, and all of those tools are like, everything's a big ball of wax. We need to release that together. How do we do that in a smart way? And so this highly coupled big ball of stuff kind of has twisted DevOps in some odd ways, which kind of makes me really interested in it. And I don't know, Brandon, you've got the architecture background.
Yes, yeah. So I've done that for about 20 years, and I've seen a little bit of everything, every kind of type of deployment architecture that is out there, and I think there's very often not the consistency you would expect, and then you have the different departments that need to understand how that thing's going to get deployed, and yeah, it can be very interesting to see the different configurations you end up with, and generally the documentation that doesn't exist around those.
Yeah, no, exactly. All right, so that kind of motivates us and what we're looking at, and informs, I think, this data architecture view that we're going to get into. I forgot as we started to mention to participate in the live Q&A. It would help if you went into the questions panel and dropped in questions. So as we go, feel free to ask them. We might be able to answer them as they're coming in. We might save them all for the end when Dave comes back in. So just let you know that that's out there. All right, so where we're coming at this problem from is we've been working with a lot of customers, and our customers use the sort of tools that you see here on the right that allows you to really double click into that kind of crazy whiteboard and see the details that are actually underneath, and really get into the truth of how the structure actually is rather than what you hoped and intended at some point in the past. So that's our background, and what our customers are doing with this is they're using it to see all of their dependencies and tackle some gnarly architectural challenges, but fundamentally it gets to that you can see what's actually going on within the application and how it really fits together. So that's what we've been engaging our customers around. And that kind of brings up the, well, how did you get to this data architecture is important topic. So with that, it kind of gets to the interactions we've had with our customers as we've worked with them around this sort of stuff over the last 6 months or year. And fundamentally, like, applications are really, really complex these days. And I think I kind of understood that as, you know, you've got all these crazy dependencies that are coming in through, you know, Maven bringing in the whole internet, or these microservice architectures where you got lots of moving pieces and event buses and all that stuff. And of course, each of those things are bringing in the whole internet, whether that's through, you know, your Maven stuff or your NPMs. But like, when we've actually like done the analysis, Brandon, like, you're seeing things that surprise too.
Yes, yeah. The first time we decomposed a customer's application, it was enormous. We expected somewhere in the neighborhood of about 200,000 nodes, just different parts of an application, be it, you know, methods, classes, connections to databases. And it ended up the relationships and individual parts of that application came in at around 2 million. And that was for a single enterprise application. So it was much bigger than we expected.
Yeah, there's a lot going on here. But I think more to the point for today's webinar, like, there's this idea that like data architecture is destiny, and you know, as we've worked with clients around the most gnarly bits of their code and just kind of where the complexity seems to accumulate, it seems time after time that's caused by mismatch between what kind of the business logic was trying to achieve and how the data is architected. And that pattern, I think, has really struck both of us, right?
Yes, it did.
So, you know, what we want to do here is look at a couple of examples and a couple of ways that this can crop up, talk a little bit about what you might do to unwind it, enjoy a little bit of the tool-generated modern art along the way, perhaps. So let's start with one that you know, gets into, you know, the workflow engine or the job management engine. You know, we're in a DevOps era, we're in a digital transformation era. We automate things, right? And there's work and it has some logical flows and it's distributed across networks, and we all have lots of these things. You know, in one environment where an application was being brought in through an acquisition, and you can just see one of the architects being like, oh, we just got it down from 30 workflow engines in the company to 15, and now you're bringing in another one. Okay. We all have a lot of workflow engines running around. And so we see this pattern a lot. And Brandon, as you worked with a couple of these companies, you saw the same thing cropping up like at startup time, right?
Yeah, one of the common patterns is everything's checking state at startup. You know, did I shut down correctly? Have all of the migrations been applied? All of that. And then once you start kind of looking at, you know, initially whenever you first set up the application, everything starts up pretty quick. There's not a lot of migrations to run. And then over time, that startup process gets slower. There are more migrations, more state to check. And then you get kind of into some of the gnarly queries where it's, you know, your ORM generating a query that this thing's been bolted on here and this thing's been bolted on there. You have left outer joins, and over time, that performance at startup is just less and less there, and you're waiting longer and longer. That seems to be a very common pattern.
Yeah, and that slow startup, as it's checking, like, hey, was there work left in flight when I was shut down or crashed? Say shut down. Like, that's actually pretty relevant, right? Because if there was work in flight when the system went down, there's probably someone who really wants that work to be completed and doesn't want to take a long time for the system to come back up, right? And so exactly the cause of the slowdown is exactly the thing that wants it not to be slow, which
yes,
seems to be true in so much of life. But with this sort of thing, like, you know, we were talking about this earlier, and like, there's things you can do, right, to anticipate this sort of situation and kind of tweak the data model in some ways that would make it not as much of a problem at the start.
Yeah, some of the things that we've worked with customers on is either using summary tables that can then be used to kind of keep the data a little bit more local. You cut out some of those left outer joins. If caching is a possibility, you know, you can implement that, and it definitely helps in that startup process. So it can get back to that job that was happening whenever you didn't shut down cleanly, and kind of gets things back up and running more quickly.
Yeah, so the kind of information you know you're going to need to pull together later, pull it together as it's in flight, so that if you need to say where is everything, you've got it all in one place, right?
Yep.
Okay. I'd imagine that could also help if we're trying to anticipate some sort of a modernization where we might want to break up this app. Having the where was everything centrally or in a startup area would probably be helpful too.
Yeah, absolutely.
Yeah. So yeah, I think thinking about where that data is, making sure you've got it lined up into the services that are going to need them in the performant way when it needs to perform, that helps. And then it simplifies your queries. You're talking left outer joins, which I vaguely know is nasty, but I'm not the architect and I've always been bad at data. But yeah, try to anticipate it, bring it centrally. Got it. Cool. So let's go from this kind of relatively concrete thing to a more abstract pattern that we see all the time in modernization, right? Which is this idea of let's break down the monolith.
This pattern's very familiar.
I'm sure we've seen this all before. So the pattern that we see people do is it's like, all right, I've got a big monolithic app. It's talking to a monolithic database. I am going to pull services out of the app, right? And there's approaches for doing this, like the strangler pattern and things like that are all Googleable, and you'll see this kind of fun. But you take the services out of the big monolithic app, and then you know, okay, we should then break up the data to match those services so that every service has a corresponding set of data that belongs to it. And we integrate at an API layer between the services rather than, you know, way down in data land. And, you know, you get this kind of flow. And this works really well and doesn't have any problems, right, Brandon?
It works every time. There's never been an issue, and it's always seamless.
I need you to disagree with me.
Yeah, typically step 2 is usually where you get to, and then it's about it. So
yeah, because like if the data is highly coupled, right, for lack of a better term, it can be hard to split it in the same way that you wanted to logically split those runtime services. I think we've all seen teams kind of get to that point, start down the path and go, this is 3 years of work. Is that really where we want to spend the time? And someone decides no, right?
Yeah. Oftentimes if you tackle it in reverse and kind of look at the data, look at how you're going to partition that data and work in reverse, it kind of lends itself to where does the application how can the application logically be broken up? So once you figure out how that data can be partitioned, then it kind of helps you build out those microservices, and it usually makes for a good first start.
Yeah, yeah, and you know, we were trying to sort out how to talk about this, and we went for a visualization. So let's start with the one that kind of makes sense. And I know this sort of visualization can be a little bit overwhelming, but we do have a bit of a legend down here. So up here you've got some jar file or WAR file, some executable. It's talking down into your classes. All this purple and the tan stuff is classes breaking down into methods and fields. You got a lot of blue bars down here, which are kind of how your Java code or what have you is talking down into database columns. And then the brown is the same thing, but table to column. And then you got a little bit of this pink or salmon that's column to column relationships, which are foreign keys. I think what we like about this Internet of Things application is that you can really visualize a hierarchy here. And while it's not boring, you can kind of see some vertical stacks, right? I don't quite know a better way of expressing it.
Yeah, there's some obvious obvious pieces of this where you could kind of look at it, see that things aren't too crazy, aren't too interconnected, and you could kind of pair those off and break them up into their own kind of services without incurring too much pain.
Yeah, it doesn't look like the data is too outrageously coupled here. There's a handful of foreign keys. Generally, the classes and the data structures line up pretty cleanly to the tables and columns. And so you could probably actually, if you'd gone about it, you know, this way, and you just said, well, what would I logically want my data or my services to be? You might have just got lucky on this one, right? This is clean enough that, you know, you have a decent chance that you'd actually cut it in ways that it wouldn't be too bad to unwind.
Yep.
So that's what one kind of app could be. We're going to jump to the other end of the spectrum here, where we look at it here. So same sort of legend, but the whole app here seems to be connected into the data. So unlike this one, where there were big chunks of app off here on the right that weren't terribly tied to the data structure, it could probably be their own thing, some reporting service that's just talking to APIs over here. That would work. You don't have a lot of that here. And when you start looking into the data, it's a freaking mess. I don't know.
Yeah, this is scary. There's a lot of tight coupling between the data here, and it's a pretty scary scenario where I think unwinding this, your best option here is to initially, if you have to go to the cloud and your if your desire is to get to the cloud, you throw it in a container, you ship this thing as a monolith, and then you start kind of looking long term where you can parse the thing out and how you're going to actually break this down into something more manageable. But it's definitely a longer term endeavor than the other example.
Yeah, you're hitting like the political reality that a lot of teams are faced with, right? Which is like the CIO has come and said, we are going to move 90% of our workloads to the cloud in the next 3 years. It all needs to be cloud native microservices. And when you get those kinds of mandates, that's when you, if I go back, get to like step 2.5, you look at it and go, it's a lot of work. We're just going to declare success and move on, right? Because we can just, in the PowerPoint presentation that goes up to my manager's manager, just mark it green. And we'll see it. And you see this sort of thing in all sorts of surveys, right? Whether it's about DevOps or cloud native or anything. If you ask the CIO, you know, how microservice-y are you? Like they give a score up here. And then if you ask a random person in the CIO's organization who's down at a working level, how do you rate it? They rate it down here. There's always this like 30% gap between what the CIO thinks is going on and what's actually going on. And it's this sort of thing where you look at this and you say, let's just say it's good, right? And you do an analysis of an app like this, which a lot of teams, you know, we're eyeballing it here, but a lot of teams will spend, you know, 3 senior engineers for a month or 3 really trying to understand it before they go, yeesh, yeah, this one ain't happening or not, right? So doing this is hard. And I think because we already know by looking at the data tier that this is going to be hard, we can save a couple of months of the analysis that you might have otherwise spent, like reading a bunch of Java code up at the top and trying to understand how that all works together. Hitting the data, you know whether you're ever going to get past step 2, right? And that can make your decisions a lot better. So hopefully that makes sense. If I was going to like do one basic thing, I think it would be just check my database and do a rough count of foreign keys.
Yeah, there's a whole layer there of foreign keys in this example, and it would be a really good place to start.
Yeah.
Why do those exist, and why is that so intrinsic to what's going on here in this particular data structure?
Yeah. So why don't we give ourselves the impossible job here? And let's say, okay, so if we're gonna go and try to fix this thing, right? And break it down, like how would we start in 10 minutes or 5 minutes? Like how would we go about this? And like, I think Brandon, you're probably right. The answer is don't just put it in a container and chuck it at your local cloud service and say, we did it. But if we were to really legitimately try this, and this is the same sort of stuff we do with, some app that's between this quality and this quality, like, what would we do about it? So I'm going to do your job. I'm going to pretend to be the architect.
Okay.
And then I'll let you be, the senior developer. Once I find some data structures that look interesting, I'll let you dig into the code. Because I'm more of a boxes and lines kind of guy, not a code kind of guy. So we'll try that. All right, let's see if I can bring up the same view of the app. All right, can you guys see this? Am I sharing my screen correctly?
Yep, looks good.
Yep, sweet. All right, it's cool. All right, so I've got this same visualization, and we already said that we care a lot about the foreign keys. If I look over here at my data, and depending on your screen size, you may or may not be able to read this. I threw this onto my giant screen. Looks like we got 125 foreign keys down here. And generally how this algorithm works in the visualization is things that are the most coupled and messiest tend to be in towards the middle, at least of their layer. So I'm just gonna aim to zoom into the middle of this pink layer. And as I get closer, the structures change. And sure enough, there's something really dark in there. And we'll zoom in and zoom in, and sure enough, it's something called an ID. And I see one blue line, and that was my connection out to some Java method. Green line, that's my relationship out to my table. And I can't count how many pink lines there are. There are a lot of pink lines there.
There's a lot.
So there's a lot here, and I might want to drill in some more. I can see that this is in my CCDB schema. I've got an assets table and an ID. It's always something like assets, right? It's some word that means thing or person, right? Like the most generic terms you can have. Those are our problem areas. This looks good, and this might resonate with me. I may have been talking to my SRE team, and they've been saying that, yeah, our data ingestion of stuff, assets, is slow. So I'm being mean to this app because I know it was a kind of throwaway prototype, so I feel comfortable with that. So if we open this thing up, right, and dig in on the web browser, whoops, see if I can get this to share correctly. See, I've got a bit of a sharing issue, it would appear, but let's just say I dug in, I got the information, I said that looks troublesome. I want to throw it over to my buddy Brandon to dig in a little bit deeper. Let me let you share, Brandon, and then you can dive in from the perspective of what this looks like in the web interface and how you go get into the code from there. So I am going to stop my sharing and then make you the presenter.
All right.
And now you should be able to share your perspective.
Okay, so you should be able to see my screen.
Looks great, man.
All right. So, so what we have is I've identified that that ID column, thing ID, and calculated an impact to see kind of all of the other things that it is actually connected to. And kind of looking at it, it's connected to a lot of stuff. And I want to see kind of, okay, I've identified it, I know it's connected to lots of stuff, and I want to actually jump into the code and get an idea as to, you know, what it is that's driving this. So we see that it's connected to asset, and that's part of our domain model, and we want to take a look at that. So we jump into the code, and here we have assets, and this thing is connected to lots of stuff, and you want to understand what it is that's going on. So you start getting into it, and you see you have some collections that are lazily fetched, some that are eager, and another collection that's eagerly loaded, some more lazily loaded collections, and that's kind of interesting. And you start looking into, okay, I want to know all the things it's connected to, and sure enough, it matches what's in our graph, and you have lots of stuff that use it. One of the interesting things when we were working
Brandon,
on.
could you actually bump your font up one or two?
Yeah.
It just looks a little small, probably the same problem I had.
All right. Let's see here.
If that's more than a control plus, you might not need to.
It apparently is more than a control plus.
Okay. Yeah. Continue. I can mostly see it.
Okay. That was not a contingency I'd planned for here, so my apologies. So with the assets, start looking into kind of where's this thing used and how is it being used. And if we see that it's extending audit base entity, one of the things when we were working on this that was interesting is we found that audit base entity actually then contains assets that are transient. So they were never stored, but this thing that extends this thing actually contains some of this thing. And those objects were then used by source files. So one of the particular problems with this application is things were slow at ingest time. So you're shoving a lot of data into the application and things are slow. As it turns out, source files extends audit base entity as well. So it loads this collection. Though many of the collections on that are then eagerly loaded in a kind of a cascading effect. And none of that was actually necessary except for presentation time. So we found that it was extremely slow, but it didn't need to be slow, and it was only needed for presentation. So one of the things we were able to help with here is you wrap this thing with some DTOs, only load those assets at runtime whenever you're doing a display, as opposed to during ingest, and that was beneficial for this. So that's kind of where I would start, and then in breaking this out and kind of removing a lot of the dependencies on this asset object.
Yeah, so we're working from just some rough data of there's a lot that depends on this thing. This is where we're going to take a really careful look and then start saying, well, if this is in the middle of everything and we've got some not well-tuned hibernate annotations, basically, that's worth spending some real time on to start addressing, right?
Yep.
Okay. I'm a retired developer. I'm hoping I'm understanding. So.
All right, I'll hand presenter back to you.
Okay, and then let me get some slideware back up. And we're moving, got a couple more questions for y'all, and then hope that you have questions for us as well. Be happy to talk some more as we move into Q&A. All right, so there we go. We're back to slides.
All right, looks good.
All right, cool. All right, so with that, let's do one more poll. You know, we were doing our own stuff around software dependencies. Just kind of curious how you all do your software dependencies. So we wanted to run the second poll here and see, are you doing this manually? Do you have some sort of a tool for it? We've talked to a bunch of people who bring in consultants like Deloitte or Accenture to try to map this out for them, or just give up and don't do it. So curious what you're saying here. This is so far in a bit of a split between manually and just not doing it. It's manually wins. All right. As a DevOps automation guy, I'm heartbroken, but not surprised. So okay, no, that makes sense. So kind of dig in yourself and understand it. Maybe we're drawing diagrams, and there's probably a lot of clicking around and just trying to come to terms with what you see and building the mental models. All right, so thank you for playing along. So yeah, and we did a couple examples of how folks are using our stuff. Definitely see them, trying to catch dependency changes, make sure you don't have things that slide out the door that you didn't want. We had an issue where we almost shipped a test library, which was not great, but we were able to say, hey, what's all that new stuff? Yeah, that's not what we wanted. But I think more excitingly, like really enabling you as you move into the architectural change and putting some rules around that, right? So if we had that crazy foreign key environment, we could say, yeah, let me know if there are more foreign keys to any of these entities and get alerted when that happens. So as we start moving in the right direction, we can make sure we don't backslide. Because I think any team lead architect knows you try to put in place, the policies, and someone's just trying to make a feature and they violate it, and it can be hard to catch. Things change pretty quickly without you. Cool. So with that, we're moving into Q&A. As you're putting in questions, we would like to say that feel free to reach out to us. We're hiring all over the place right now, which is a lot of fun. I'll go back to resume reading this afternoon. And if you'd like someone like a Brandon to kind of help you with one of your applications, we'd love to wire it up, break it down, and talk to you about it. One of our favorite ways of spending time. So yeah, reach out to us. I think we'll push that out in the chat as well. And slide into Q&A, which is probably more entertaining than me talking about stuff we'll do.
Well, I don't know that I'd go that far, but I would say I really enjoyed the role playing on the unwinding of the code base there, where you played developer, and that was good. But it led me to think, and I'm wondering, so what exactly is the relationship between like a DBA, a dev, and the architect when all this is kind of coming together and you're trying to unwind it all and see how you can break it down?
I think that's going to, I don't know, I'll start, and Brendan, you can tell me how wrong I am. I do think it's a good opportunity for collaborative stuff, right? Oftentimes you've got the DBAs saying, guys, you got this like crazy query that's, not performing well and it's a total mess. The developer may know where that's coming from, although I think we've certainly encountered places where those queries are really dynamic and it's hard for them to find it. And then the architect would be in a good place to start talking about that data architecture shift. How have you seen it, Brandon? Kind of the roles there.
Generally, it's pretty good and collaborative. I mean, you there's definitely that kind of collaboration piece where your DBA, is going to drive a lot of that. If you're doing it right, that is kind of where fundamentally the application structure comes from. whether or not you intended it that way, that is often the case. I mean, your data and data structures really do drive the end result of what the application looks like. So there's got to be that kind of constant collaboration piece there. Yeah.
Yeah, and I think one thing that strikes me is as we've gone through these agile transformations and these transformations towards teams that are, you know, your two pizza team, right? When you have this team of like 6 to 8, 10 people, you often don't have the full-time DBA on it. You don't have a dedicated architect on it. In a lot of organizations, the title of architect just is synonymous with senior developer. And so a lot of the data architecture as well as architecture is just being done by developers. And, you know, I think what we need to enable as an industry is better models for the professional DBAs who really understand the intricacies of databases and professional architects who've devoted their lives to learning this art, helping them be more consultative, right? Helping them parachute into these teams and help them out through their challenges. And that I think is a place where we have a real challenge in the industry right now. The architects and DBAs are often too much on islands and not well enough integrated into the teams because we've worked so hard to make the teams, you know, this cross-functional, self-sufficient, and that's all great. But they often don't have the deep expertise. We got to figure out how to, like, deep expertise comes and goes.
Yeah.
So, does that help, Dave?
I think that answered it. Appreciate that. I wanted to talk about the visualization you guys did with the microservices was really great, but it didn't seem to take into account business objects or the business concept. Is this approach kind of limited in any way, or did I miss something? Brandon, maybe you can, or Eric, either.
I don't know, Brandon, do you want to start there? I think it's probably a fair criticism of how we did this in a short webinar.
Yeah, I would say that's a fair criticism. I don't actually have a good answer for that, Eric. Please go ahead.
Yeah, sure. Yeah, I mean, I think the data architecture provides constraints, is how I talk about it, in that it tells you what things are easy to split apart from each other and which are not easy to split across each other. The business domain, the business objects, those sorts of things, that thinking probably tells you what you should move apart, right? And you're probably looking for some sort of a union between what should be separated conceptually and what you actually can. And you want to stitch those two things together. But frankly, the understanding of the underlying business concepts, I think is a really cool thing that we're seeing in the industry. The desperation a lot of organizations have to keep business talent, people who understand the business in New York, is really cool. I saw a talk, I think it was from Liberty Mutual. If not, I apologize, but it was some big insurer, and they were trying to push from half their IT force being developers to 3/4 of their IT force being developers, something like that, which made it tempting for them to just lay off half their non-developers and hire a whole bunch of developers. And what they did instead was offer to retrain half their non-developers to be developers. And you know, if you're retraining someone, you're putting them through coding boot camp, they're not going to be the best developers you could get, right? Just they're new to it. But they're people who understand your business, and understanding the business concepts is going to help you make those decisions so much better. That has a really profound impact, whether you're re-architecting, whether you're just creating a new feature, whatever it is. Understanding the business is so critical that Like I love that the industry is starting to recognize this and do smart things around it. That may not have been the right monologue, but it's one of my favorite topics.
Well, it seemed to address the issue, so appreciate that. Okay, we have one final question, and then we'll throw it back out to you guys for final thoughts and takeaways. So in your platform, are you also able to look at the relationships between microservices? I know you're breaking down the big apps into these small pieces. How do you track the relationships?
Yeah, and one of the things that I think we touched on real briefly is the importance of like the dynamic relationships, and some of that is at the data tier, right? Everybody's got that method in there. It's probably for reporting or something that generates some wacky queries that you won't otherwise see in your standard annotations and Hibernate and all of that, and you want to pick that up. But you also need to pick up the relationships between all these runtime services, but especially as you start breaking them out, right? So start at the database, at the data layer, but then as you break it out, you should still have an eye on the data layer. You want to make sure that services aren't talking to the wrong databases and stuff. Like that's really toxic. But yeah, absolutely, we'll keep track of those REST API calls and calls out to message queues and stuff.
Yep.
Yeah.
Okay, excellent. All right, so so let me put it out to you. I guess, Eric, maybe we'll start with you for final thought and takeaway. If there's one key thing folks need to know when they leave here today, you know, what would it be? And then Brandon, will go to you.
You know, as developers, we love our code and we love to think about the REST service and, you know, how things are coming in from the outside and all of that. And databases are hard and gnarly, and we often don't know them as well, right? And so we tend to shy away from there. If we're going to do the real re-architecture work, we got to embrace the unpleasantness of starting with the data and building back up, because the other one just doesn't work. Brandon?
Yeah, I think my main takeaway is at the end of the day, you often start with code and then get to the data. And when you see how an application ends up being architected, it really is the data that drives everything else. It is the thing that drives the models and the rest of the application. So if you spend more time kind of focusing on that data architecture, it really does help to understand the rest of the application. So
Make the rest of the app better.
Yep.
All right, excellent. Thank you, Eric Minnick, Brandon Tilkey from CodeLogic. Thanks for being with us here today. Appreciate it.
Thank you.
Thank you. It's a pleasure.
And thanks, of course, to CodeLogic for sponsoring today's session. And of course, to all of our attendees, thanks for watching. Until next time, once again, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.
Thanks.
Cheers.